Hello everyone. In this video, we are going to discuss about bitwise shift operator in C++. C++ has two bitwise shift operators. We will be discussing these bitwise shift operators in C++. So let's check what type of bitwise shift operators are available in C++ and how does this shift operator work. So C++ has two types of bitwise shift operators. First one is called right shift and second one is called left shift. Right shift and left shift. So right shift operator is with this symbol and left shift operator is with this symbol. So what right shift do? First we will check about right shift and then we will move to left shift operator. What right shift operator do? It needs, first of all, it needs two operands. It is a binary operator. First of all, it is a binary operator. It means it needs two operands. Second one is it shift each bit from left to right. It shift each bit from left to right and which bit? Bit of first operand. So how this operator works? I will show you how this operator works. So let's say we have one variable. Let's say we have one variable and let's say we have one variable a and value of a is equal to 10. Fine. Now if I write a 2, so it means here we are using, this is bitwise right shift operator. See, this symbol represent one more operator. If you remember, I told you when we use this symbol with C in, this is known as stream extraction operator. When we use this 2 greater than symbol with C in, then it is known as stream extraction operator, and when we use with some variable, then it is bitwise right shift. Now how it work? It will shift bits of first operand towards right from left. So first operand is 10. So when we are talking about bit, it means first it will convert this decimal number into binary. So binary equivalent for 10 is 1010. So let's say this is our number. Now it will shift bit from left to right. From left to right. How much bit? Whatever is second operand is number of bits that to be shifted. So it means it will shift 2 bits from left to right. So these 2 bits will be shifted from left to right. So it means now these 2 bits will be shifted. So it means these 2 bits will be lost. So 10 and the blank space will be filled by 0. So now our result will be, this is binary equivalent to decimal number 2. So now result will be 2. Let's check one more example. Okay. So let's say we have another number a is equal to, let's say 11, or let's take a is equal to 10. But now I write a right shift 3. So when I write a right shift 3, it means now this bitwise shift operator will shift 3 bits of a towards right. 3 bits of a towards right. So it is 1010, and when it will shift 3 bits of a, it means these 3 bits of a will be shifted and it will be lost. So it means now our equivalent will be, this 3 bits will be shifted towards right and now our equivalent will be 1 0 0 and 0. So our answer will be 1. Now 3 bits will be shifted towards right. So these 3 bits will, from left, 3 bits will be shifted towards right. Let's take one more example. Let's say variable a is equal to 11 and I write a right shift again 3. So binary equivalent to this number 11 is 1011. Now 3 bits will be shifted. So now our answer will be again 1, 0, 0 and 0, 1. So first let's check it to the Visual Studio, then I will tell you a trick for doing this. So let's say a is equal to 10 and let's say a will shift 2 digits. So here if I print a, so now a will be a will be 10. A will be 10 and if you store it in some variable, let's say b is equal to a this, and when you print b, and a is equal to a. So a will be 10 and b will be 2. A will be 10 and b will be, a will be 10 and b will be 2. When we shift 3 bits, so for example, if I replace it with 3 and I'll run it, so answer will be 1. Now b will be 1. Now let's say we change the value of a. Let's say a is 11 and when we run it, so now you can see that again answer is 1 because binary equivalent of 11 is 1011 and when 3 bits will be shifted, then at the end we will have 1. So when at the end we will have 1, it means 1 will be at the end and 0001 and answer will be 1. So this is bitwise right shift operator. Now we have a trick also for this bitwise right shift operator. What is the trick? For example, let's say you have to write a is equal to 10 and you are applying this bitwise right shift to 10. So first thing is that whatever number is here, that will be the number of step. So in this process number of steps will be 2. What you have to do? Which number you have to shift? 10. So every time you will divide that number by 2, and since this is an integer division, first time you will get 5. Now how many times you have to divide? Number of steps. You have to divide it 2 times. So second time divide this. 5 divided by 2 and the answer is 4. So this 4 is going to be your answer. Okay, every time you will divide by 2. Now for example, let's say a is equal to 10 and you have to shift it 3 times. Now number of step will be 3, but again you will divide it by 2 because this is about binary numbers. So 10 divided by 2 is equal to 5. Now in the second step we will divide 5 by 2, answer will be 4. Now in the third step we will divide 4 by 2 and answer will be 2. Sorry, in the, this answer will not be 4, this answer will be, I am sorry, here when we divide 5, when we divide 5 by 2, answer will be 2. Again when we divide 2 by 2, answer will be 1. Number of steps will be 3 because here we have to shift 3 bits. Here number of steps are 2 because we have to shift 2 bits. So answer will be 1. Now let's take one more example. So let's take one more example. Let's say A is equal to 13 and we have to shift it 3 times. So now number of steps will be 3. So in first step we will divide 13 by 2. Answer is 6. We always use integer division. Just keep this mind. We will use integer division here. Now here we will divide 6 by 2. So answer will be 3. And then we will divide in third step 3 by 2. Answer will be 1. So 1 is our answer. Let's check it on Visual Studio for A is equal to 13. So when we divide A is equal to 13 and B is equal to we want to shift it 3 times and we want to check the value of B. It should come 1. It is 1. If you want to check it, let's check it one more time. Let's say A is equal to 13, but now we want to shift it by 4 bits. So now number of bits will be 4. So first 13 divided by 2 comes out to be 6. Second step 6 divided by 2 comes out to be 3. Third step 3 divided by 2 comes out to be 1. Now fourth step 1 divided by 2 comes out to be 0. Again I am repeating, we are having integer division here. So let's check here. A is equal to 13, but now we want to shift it 4 bits. So our answer will be B will be 0. B is 0 here. Now the second one is bitwise left shift operator. Now second one is bitwise left shift operator. What bitwise left shift operator says? So bitwise left shift operator. So first of all the symbol is this. When we use this symbol with C out, then it is known as stream insertion operator. And when we use it with variable, then it is bitwise left shift operator. So first is same, it is a binary operator, it needs 2 operands. Second one is shift bit from the right shift from left to right, left bit shift from right to left, right to left. But in the left shift operator, compiler converts into 8 bit. First compiler, like we did operation in the only on the 4 bits in right shift, but in left shift compiler converts into 8 bits and then it performs operation, because it is shifting left towards left, and if it doesn't find anything in the left. And why it is converting into 8 bit? Because 8 bit equal to 1 byte, converts into 8 bit system. And then shift from left to, then shift from right to left. So let's say I write here again, let's say I write here A is equal to 10 and I say A left shift 2. So first of all compiler converts it into 8 bits. So in 8 bit representation 10 will be represented like this and rest all bits are 0 0. Now how many bits it want to shift? It want to shift 2 bits from left to right. So when it shift 2 bits from left to right, answer will be here 2 zeros and then 0 1 0 1. Zero and 0, because it is 8 bits. So this will be the binary equivalent to 40. For example, let's say I write A left shift 3 times. So let's represent it in 8-bit system. A is again 10. So A will be represented like this. 0 1 0 1 0 0 0 0. Now it will shift 3 bits towards right. So last 3 bits will be 0. And then 0 1 0 1 and 0 here. So this is binary equivalent to 80. So first let's check it, and then I will tell you one trick also for performing this operation. So now we are checking about bitwise left shift. So let's say is equal to 10 and we want to shift it left 2. So now our B should comes to 40. 40. Now if I say 3, then it should comes out to be 80. Yes. Now let's check a trick about this bitwise left shift. So trick is simple. Like bitwise right shift, let's say we have number A is equal to 10 and I want to shift it 2 bits towards right from towards left from the right. So what you have to do, how many number of steps? Number of steps will be the number of bits you want to shift. So it means in this operation number of steps will be 2. Here to the number, instead of dividing, you should multiply by 2. 20 and then multiply 20 by 2. That will be 40. And you know the answer is 40. Similarly, let's say I want to shift this A 3 bits towards left. So it means now number of steps will be 3. Instead of dividing, we will multiply it by 2. Why we are doing every time by 2? Because it is a binary number system. Now 20 asterisk 2, 40, again 40 asterisk 2 is equal to 80. Fine. Now let's say our A is equal to 11 and what I want to shift to left 2 digits. Let's take 2 digits, it will be very large number otherwise. 2. So number of operations are 2. 11 into 2 is equal to 22 and 22 into 2 is equal to 44. So our answer should be 44. Let's check it here. Now A is equal to 11 and we want to shift it 2 bits towards left. So B should be 44. See, so these are bitwise left and right shift operators. So bitwise right shift right from the left, and it is a binary operator. It needs 2 operand. It shift first operand equivalent to the number of bits of second operand. And same bitwise left shift, it shift from right to left, and it is also a binary operator. Thank you.